This is the second lesson for day 5 for Algebra 2. So for the second lesson, we're going to learn how to solve quadratic equations using the quadratic formula. So the quadratic formula is there on your screen. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. First thing we're going to do is a quick review of simplifying radicals. So we're going to simplify the following by making factor trees. We want to use at least one perfect square. So over here to the left, I'm going to make a list of our perfect squares. So to find your list of perfect squares, you're just going to start at 1 and you're just going to start squaring every number. So 1 squared is 1. 2 squared, which means 2 times 2, is 4. 3 squared is 9. 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 64, 81, 100, 121, 144, 169, and we could continue on as high as we want. So we're going to look for ways that we can break apart these numbers underneath our radicals to something times a perfect square or a number on this list right here. So when I look at 72, I know that 72 is equal to 36 times 2. So the square root of 36 times the square root of 2 is equal to the square root of 72, because 36 times 2 is 72. Well, then I know that if I take the square root of 36, since it's on my list up here, I will get 6. So this becomes 6 times the square root of 2, which would be my simplified answer. Looking to the question on the right, I have the square root of 160, which separates into the square root of 16 times the square root of 10. I know the square root of 16 is 4, because 4 times 4 is 16. And then my square root of 10 gets brought down. So that's a quick review of simplifying radicals. We're going to need to remember how to do that for the quadratic formula. So again, here's our quadratic formula. You're going to want to either memorize this or just make sure you know where it's at on your reference sheet for your tests. So for our first problem, we're going to use the quadratic formula to solve x squared minus 6x plus 8 equals 0. It's very important for these problems that we do have 0 on one side. So if we don't have 0 on one side, we're going to move whatever's over there to the other side. But in this case, we do have that 0, so we're going to identify our coefficients. Whatever number's in front of x squared is considered to be a. In this case, there's nothing written in front of x squared, so we assume that it's 1. B has a value of negative 6, and C has a value of positive 8. So now we're going to our quadratic formula, and we're just going to replace a, b, and c with those 3 numbers. So x equals negative b. Negative b means I'm going to look at the b value, and I want the opposite of the b value. So in this case, b is negative 6. If I want the opposite of negative 6, I'm going to write 6. So 6 plus or minus the square root. And when I do my quadratic formula, I just go ahead and put in all my parentheses and fill them in just a minute. So now I want b squared, so I want negative 6 squared minus 4 times a, which is 1, times c, which is 8. And then underneath all of this is 2 times a, which is 1. Notice my fraction bar goes underneath everything on the top, so it's not just one little tiny fraction bar. It all gets divided by that 2 times a. So now I want you to take this highlighted section right here, not including the square root, and I want you to type that in your calculator. Make sure you use parentheses. So when you type that in your calculator, you should end up with a value of 4. And then for the denominator, I went ahead and simplified 2 times 1, which is just 2. So now I have to investigate this square root. So I have to decide if 4 is a perfect square or if I just need to simplify. In this case, 4 is a perfect square. So I'm going to have 6 plus or minus 2 divided by 2. So I took the square root of 4 out and I replaced it with 2 because the square root of 4 is 2. When your square root disappears in your problem, you're going to have to break up the plus or minus sign right here. So you're going to have one problem with 6 plus 2 divided by 2 and another one with 6 minus 2 divided by 2. And you need to simplify both of those problems. So 6 plus 2 is 8, divided by 2 is 4. So there's one answer. The second one, 6 minus 2 is 4, divided by 2 is 2. So here we have two answers, positive 4 and positive 2. For the next question, we want to first start off and take this equation and we want to write it in standard form. So standard form is that ax squared plus bx plus c. We never want to move this term and make it negative. So I want to leave that term right there and I want to move the 6 and move the 2x. So that will give me 0 on the right side. When I write the terms for the left, I want the 5x squared first. Then I want the linear term, or the term with just x, to come next. Just like that. So now these are in the proper order for me to identify A, B, and C. So A is 5, B is 2, and C is -6. Now that I have those values for A, B, and C, I'm going to go ahead and plug into the quadratic formula. So I want the opposite of B. So the opposite of 2 is -2. Then I just went ahead and filled out the rest of my quadratic formula with blanks or parentheses to fill in. So then I want inside or underneath my radical, I want b squared minus 4 times a times c, and then underneath 2 times a. So again, now I want to take what's underneath my radical and I want to type that into my calculator. Everything else we're going to leave the same. So when I type it in my calculator, I end up with 124. And then for my denominator, 2 times 5 is 10. Once I get here, I know that 124 is not a perfect square, so I'm going to take 124 and I'm going to break it up into two numbers that multiply to give me 124, and then I want one of them to be a perfect square. So 4 times 31 is 124, so I know the square root of 4 times the square root of 31 is equal to the square root of 124. And then I know the square root of 4 is 2. And then I'm going to leave the square root of 31 out at the end. So 2 times the square root of 31 is how the square root of 124 simplifies. So I'm going back to my problem and I'm going to fill that in instead of the square root of 121. The next thing I'm going to do, since my radical is left in my problem, I'm not going to break it apart into two answers. I'm going to check to see if I can reduce. We can only reduce right here with our heart. The 31 is being protected by that square root, so we don't touch it when we reduce. The only thing we're going to reduce are these three numbers, the 2, 2, and the 10. So we're going to reduce by 2. So I'm going to divide all three of those numbers by 2. So -1 plus or minus 1 square root of 31. Again, that 31 is protected. We don't divide it by 2. And then 10 divided by 2 is 5. And then that right there is my final answer. One more problem. So again, we're going to use the quadratic formula to solve this. The first thing we want to do is write it in standard form. This time, all we need to do is move the 11. So we're going to subtract 11 from both sides, which gives us 2x squared plus 8x minus 11 equals 0. So once you have 0 on one side, you want to go ahead and identify A, B, and C. So A is 2, B is 8, and C is -11. Jumping to the quadratic formula, x equals -b, so I want the opposite of 8, which is -8, plus or minus, then my square root. Underneath my square root, I want b squared, which is 8 squared, minus 4 times a, which is 2, times c, which is -11, all divided by 2 times a, which is 2. So I will tell you, on my test, I give you 1 point automatically for showing me this step right here. So I want to see what you've plugged into the quadratic formula, just so I can double check to make sure you're plugging things in correctly. So now, once I have that done, I'm going to type this highlighted portion into my calculator. When I type that into my calculator, I end up with 152 divided by 4. So now I'm going to take 152. It's not on my perfect squares list. So I'm going to see what two numbers I can get that multiply to give me 152. But one of them must be a perfect square. The larger perfect square is always best. So here, the only perfect square I can get to work is 4 times 38. So the square root of 4 times the square root of 38 is equal to the square root of 152. I know the square root of 4 is 2. So I have 2 times the square root of 38. So I'm going back to my problem and rewriting it as -8 plus or minus 2 times the square root of 38, all divided by 4. And again, the last thing I'm going to check for is to see if I can reduce. Again, we're always reducing this heart right here. The square root's protected by that radical. So here I'm going to reduce, again by 2 this time. So when I reduce both of these by 2, I would have -4 plus or minus 1 square root of 38 divided by 2. The 1 that's sitting in front of that square root is not necessary, but you are allowed to write it.